Hello everyone, welcome to this channel again. Here we will be discussing JEE Advanced previous year questions. Okay, so first we are going to start with the kinematics. It will be part 1. So in every video we will be discussing 10 to 15 JEE Advanced questions. Okay, the explanation will be very broad and we will be looking this question in a better explanatory way. Okay, right, so I'll try to post the video every day containing 10 to 15 question, maybe more than one video every day. Okay, so let's start. Okay, so another thing I want to share is these questions of J Advance will be as per topic wise. Okay, so topic wise we are going to discuss these questions, right? So let's start. The first topic of our discussion is topic 1 of our discussion is a simple the basics of motion, where we have studied about distance, displacement, right? Speed, velocity, and acceleration. Okay, so first we are going to see the questions based on these topics. Okay, let's start the first question, where this is the 39th question. These all are taken from the book, okay, past year book. So let's start. Okay, in question number 1, so solution 39, right? A body start from rest at a time t equal to 0. So at t equal to 0, it start from rest means its initial velocity is 0, okay? The acceleration time graph is given. We have acceleration versus time graph. It look like this is 11 seconds, okay, and this is 10. Okay, so acceleration is given in meter per second square and time is given in second. Perfect. The maximum velocity attained by the body. Okay, now from this graph we can find some basic conclusion, that is that acceleration at every time is always positive. Okay, so acceleration is positive always. Now, particle is starting from rest means v is 0, right? So if particle is starting from rest and acceleration is positive, means velocity is going to increase, right? This means velocity is going to increase, right? Velocity is going to increase. Okay. For the further time, we see acceleration is decreasing, but it is still positive. Acceleration is decreasing, but it is still positive. What does that mean? Conclusively, that no matter what, velocity is increasing. Velocity is increasing, but the rate will be will going to be less and less, है ना? So rate of this increase will be less and less. Okay, will be lesser and lesser. So will be lesser and lesser. What does that mean is what does that mean is no so every time, for every time, velocity is increasing but the rate is less. We don't does not care about the less, we does not care about the rate. Okay, we only care about the what we have to find, maximum velocity. We have to find velocity max. So where will it be? Velocity is increasing, so velocity will be at maximum at t equal to 11 seconds. That's it. Okay, let's find it. Now we see the acceleration is what, 10 at t equal to 0 and it is 0 at 11 seconds. Okay, so first let's find the acceleration with respect to time. Okay, how? This is a straight line. So Very simple. We can consider this point as 0 comma 10, and we can consider this point as 11 comma 0. You know the equation of straight line, y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1. So let's do this. Y minus, we call this as x1, this is y1, this is x2, this is y2. Okay, so y minus y1 will be 10 is equals to y2 is 0 minus 10, x2 is 1, sorry, is 11, this is 11 minus 0, so 11 minus 0, x minus what will be the x1 is 0. Okay, so what is y here? Y is a minus 10 is equals to minus 10 upon 11, and what is x? X is t, right? So from here what will have, what will we have? A 10 will come here. A is equals to minus 10t upon 11 plus 10. Now we know acceleration is what? dv by dt, right? We will have minus 10t by 11 plus 10. Okay, so we need to integrate it. So dv integration minus 10t upon 11 plus 10, right? So what will we have? Yes. Okay, yes, perfect, into yes. So it comes out to be. So we can put limit here. So at t equal to 0, velocity will be 0, and at t equal to what? 11 second, we will have our maximum velocity. So integration, after integration, putting limit v minus minus v max minus 0 is equals to the integration of t dt is t square by 2. So it will be minus 10 t square by 11 into 2 and 10 dt plus 10t. Now we have to put our limits 0 to 11. So both have t terms. So 0 will be 0. Just I have to put 11 here. And what will that come out to be? Vmax equals to, I'm just directly putting it, minus 10 into 11 square upon 2 into 11 plus 10 into 11. So Vmax will come out to be 11 square, 111 is cancelled. This is 5. So minus 55 plus 110. So Vmax turns out to be 55 meter per second. Okay. So this will be our, right? It was a simple question, but you should know what we are doing here and here. Okay, acceleration is always positive, but it is decreasing, so it does not matter. As particle is starting from v is equals to 0, anyway velocity is going to increase. Yes, the rate will be lesser and lesser, but the velocity is still going to increase. So at the end moment at 11 seconds we will have our v maximum. Perfect. Next we have question number 20. Okay, so we have question number 20. Okay, what I can do is I can this and I can copy and I can put it like here. Uh, okay, no issue. So we can just solve it here, right? No issue, we can solve it here. Next, this question, a particle is going from A to B, moving in a semicircle of radius 1 meter as shown in the magnitude of average velocity. So this is a simple question, right? So what will we have? Okay, so I'm putting question number solution 40. Okay. can paste it, right? And then I can show you guys. Okay, so a little zoom in. What we'll have in 1 second, particle goes from A to B in the semicircular path, okay, of radius 1 meter. Now find the magnitude of average velocity. So average velocity I have to find. Okay, perfect. So we have this diagram, right? So it is a very easy question, of course. Doesn't look like a JEE Advanced question. Now the particle's original path is this, but we have to find the average velocity, right? The average velocity is what? Total displacement upon total time, the time of the path it has taken. Whatever the path is, we have to take the total displacement. So from A to B, the total displacement is what? 2r. R is what? 1 meter. So it will come out to be 2 meter. 2 meter we have, and the total time it will take. Yes, second, because the particle is moving from A to B, from A to B, whatever the path it will choose. It does not matter. We just need to find the total time it takes from moving A to B, whatever the path he is going. Okay, if he is going from here, if he is going from here, it does not matter. The time will still out to be, if the time is still 1 second, the displacement is always 2 meter, then the average velocity comes out to be 2 meter per second. Okay, yes, that was an easy question, right? So this is done, this is done. Okay, perfect. So it's B, it's also B. Perfect. Now, this 41 question is actually really good. So we can say this is easy, right? This question is like, again, easy to moderate, easy to moderate. Okay. This question is actually hard, right? This is actually hard question. Let's study. A particle of mass moving on x-axis as follows. It starts from rest at t equal to 0 from the point x equal to 0 and comes to rest at t equal to 1, x equal to 1. Again it comes to rest, okay? So first it starts from rest and then again it comes to rest. Now that information is available at intermediate times, and this we have to find this. If alpha is instantaneous acceleration of the particle, then we have to uh, choose the option. Okay, it is more than one correct, so maybe multiple may be correct. Okay, let's start. Okay, perfect. We are solving question number 41, right? Yes. So what is the information given? I'm just like, let me write it first. So particle is moving in x-axis at t equal to 0. Particle is at x equals to 0 and it is starting from rest, means the velocity is 0. After time 1 seconds, right? The particle position is 1 meter and its velocity is again 0. Okay, perfect. So let's analyze the situation first. Now, as particle is moving in x-axis and it is starting from 0 and end at 0, means it must have accelerated, right? It must have accelerated. So acceleration is positive. Then to stop it at x equals to 1, it must deaccelerate. So acceleration must be okay. In between, whatever he does, I know for a fact that at once acceleration must be positive and another time it must be negative, right? Let's solve it. Okay, perfect. So I don't know much about it. So let me make a journal graph. Okay, so we need to find about the acceleration. So let's make VT graph. Okay, we have this VT graph, right? So what is happening is at t equal to 0, and this is, I suppose, t equals to 1 second, right? What is happening is at t equal to 0, particle velocity is 0, right? And whatever he is doing, whatever this graph is doing, I don't care. At t equal to 1, the particle's velocity must be 0 again. Okay, so this is a journal graph. This is a journal graph. Okay, next. What another thing to mention here is particle has move 1 meter. Okay, so particle displacement is 1 meter, and we know that area of VT graph, area under VT graph, this area, right, is what? It is equals to displacement, so it should be equals to 1 meter. Yes, is there any issue with that? Perfect. Next, so this is a journal graph. Now we have to estimate what will be the acceleration. So let's go and we will see some points first. Okay, a point is acceleration cannot remain positive for all t interval from 0 to 1. This is absolutely correct. We have already found out, right? If it has moved and it is starting from 0, then it must have acceleration so that its velocity, it achieves a velocity, and then it should stop here, right, at x equal to 1. So it must have acceleration negative. So this A option is correct. Now next, alpha cannot exceed 2 at any point. Alpha must be greater than equal to 4. Okay, let's study this point. Okay, uh, let me make another graph. Okay, I'm making a graph like this. This is T, this is V. Okay, now what does this graph I'm going to show is, let's make like this. So what does this graph says is that the particle is moving with a constant acceleration, right? And then it is moving with a constant deceleration, right? So it is deaccelerating, right? Perfect. So at a time it must achieve what? At some time it must achieve. This is 1 second. This is t equal to 0. At some time it must achieve something we call Vmax. Okay. Now what can also happen here is particle initially go with a very steep, so the slope of VT curve will give us acceleration, right? That is why we are looking at VT graph. Okay. Now let's say the particle initially go with the more acceleration, right? And it, okay, so this is a simple case, right? Let's find the Vmax here. Let's find Vmax here. So what is the area here? Area will be half base is 1 second, and height is Vmax, and it turns out to be 1 meter. So Vmax will be, yes, Vmax will be 2 meter per second, right? So Vmax is what? 2 meter per second. Now, if I can make another like situation where the particle is initially going with a more acceleration and then it start deaccelerating and goes like this. So no matter what, in this situation, Vmax will always turn out to be 2 meter per second. Why? See, the pace is 1 second, right? And height should always be Vmax. So Vmax is always turns out to be 2 meter per second. Okay. So no matter which graph, which type he moves, velocity, maximum velocity will turn out to be 2 meter per second. Okay. Now, see, I have to find the acceleration at some point, right? At some point. One part says the acceleration cannot exceed 2. Another part say that at least some point it must have a 4 or more acceleration. Okay. Now, see this line. Okay, I'm pointing it out. Okay, I'm writing this graph as this is 1, this is 2, and this is 3, right? So let's say this 2 graph is in the middle, so this t will be 1 by 2 seconds. Okay, now look here. This line, if this has I mean, this has some slope, the one graph at least at some point must have some more steeper slope, right? So here acceleration will be more. Again, in the third graph, this part, this part is more steeper, right, than the two graph. Okay, so this 2 is our limiting case. This 2 hour is kind of limiting case where we will get acceleration as a minimum acceleration, right? We will get acceleration as a minimum. So if we have minimum acceleration for all these type of situation, acceleration will be greater than minimum, right? So what will be the minimum acceleration here? Yes, the slope of this second, right? What will be that? Vmax divided by this half second, right? So Vmax divided by half. Vmax is what? 2 divided by half. It's come out to be 4 meter per second square. So what we have proved just that at a particular case, the minimum value of acceleration must be 4. For every other case, we will have some point where acceleration will be greater than equal to 4 meter per second square, right? Now, there is a question arises here that what if we do like this? This is our V, this is our T, and we go like this, right? What will happen here? Okay, so this is again 1 second. This is some Vmax. We don't know about that. What will happen in these cases? Okay, now look, if you spend some time with zero acceleration, this part is what? Where acceleration is zero, right? So some distance you are moving with a zero acceleration, then what will happen when I reach at like x equal to 1 meter? Okay, after t equal to 1 second, well, what will happen in these cases? So I can't try to find it, but it's going to be a bit typical, right? So let's suppose this is t1, this is t2, and this is t3, and sometime I'm taking when I mean I'm taking some time with a constant velocity, right? With a constant velocity. So what will happen is we will get less time to achieve the Vmax. Okay, and here Vmax will be different. Okay, let us find out. Okay, so this is T1, this is T2, and this is T3. Okay, so let's find out. The area will be half sum of parallel sides. What is this? T2 plus what will be this? 1 half sum of parallel side into distance between parallel side is this Vmax. So this is our area. And what will be the answer? 1 meter, right? So Vmax will come out to be 1. Okay, so it's 2. 2 divided by 1 plus T2. Vmax will come out to be 2 upon 1 plus T2. And of course, T2 has some value. That means this Vmax is less than, in this case, Vmax is less than 2. Okay, next. Now, keep looking here. This is a very important part which I'm going to show you now. Now, if I want to find the acceleration here or here, okay, these and this, these are equivalent, okay? So for one, I can find and I can take T1 equal to T3 because of again similarity. For other cases, the slope will be much steeper, like this case, right? If I draw like this, so this slope will be much steeper. So I am taking this as a equivalent. So equivalent condition I'm putting right T1 equal to T3. What will happen now? Yes, tell me. So T1 equal to T3, then the acceleration of this slope will be Vmax divided by T1, right? Right? Okay, so acceleration will be 2 upon 1 plus t2 into t1. Okay, now I'm eliminating some of these terms. So what we have is t1 plus t2 plus t3 is 1 and t1 is equals to t3. So let me just put this here. T1 is equals to t3. So what will we have? 2 t1 plus t2 is equals to 1. So t1 will be 1 minus t2 divided by 2. So if I put here, acceleration will turn out to be 2 upon 1 plus t2. And what is t1? 1 minus t2 upon 2, right? So what we will have is acceleration will be 4 upon 1 minus t2 square. Now, what you can see here is as t2 is greater than 0, so acceleration will be greater than 4, right? Because this term is less than 1, and so this term will be greater than 4. So in these cases itself, acceleration is automatically turns out to be more than 4, right? So if at journal case like this, at some point it must have traveled with, right, zero acceleration. So what will we have? They must have more acceleration than 4, right? Right. So this was our limiting case. The second case was the minimum case. Minimum acceleration will be 4, and for all the other cases, acceleration will automatically turn out to be more than 4. So what will be the options? Options will be the B is not correct, so B is wrong, C is right. Perfect. What about D? Alpha must change sign during the motion. Bilkul, this is absolutely correct. But no other assertion can be made with the information given. Yes, so we have find two assertion, but we actually do not know what how its velocity time graph or how its path will look like. So no other assertion we can make. Okay, so the D option is also correct. So we will have A, C, D for this question. Yes. Is this clear, everyone? This is a very hard question, but it's nice. It has come in IIT 1993. Okay, perfect. Next, so I delete it or maybe it. Perfect. Let's go here, right? Okay, perfect. Let's solve this question now. So, these questions are from the topic. Oh, okay. Again, these questions are based on the topic which we call it's a free fall, right? So we can solve them, right? Mm, okay, so in this question, equation of motion will be used, right? Equation of motion will be used, right? So what we'll say 51 we will do later, okay? 51 we will do later, okay? Okay, 51 we'll do later. So first let's solve 52. So what is 52 saying is the time variation of the position shown in the graph in the figure observed in nature. So this is x, this is time t. Yeah, this is position. And the graph looks like this. Okay, so if I take a time here, this is some time t equal to t1. The particle has two position. Right, so this does not make any sense, so no. The answer is no, right? Okay, perfect. There is another question here. Let's solve this question. Let's solve this question. Okay, just give me a second. No, perfect. Okay, so what does this question say? A particle move in a circle of radius has in half the period of revolution. Its displacement is. Okay, so that is an easy question, right? So that is an easy question. So particle is moving in a circular circle, right? In half period of revolution. So let's say it start from here, it ends here. So in half the period of revolution, it will reach here. So its displacement will be 2r, right? So this will be the displacement. Displacement will be 2r, and distance covered will be this is pi r. So it is a very easy question. Yes, it come in IIT JEE 1983. So pretty easy, right? So we can say these two questions are very easy, right? Okay. Now the next part we are going to move. Next part we are going to move on. Okay. So next topic we have topic 2. So questions will be based on equation of motion. Equation of motion. Okay. Now, so we have this question here. We have this 51 question. Let's try to solve this. A body is falling freely from a given height h. It hits an inclined plane on this path at a height h. So at a height h it hits. Okay. So let me make the diagram. This is an inclined plane. This is particle. This is our particle. So this is height h, right? And it is hitting here, right? So this is height h, small h, okay, right? So height is always measured from the base. So this is our base or ground, whatever you can call. So height is always measured from the ground above. So h above it hit, right? And capital H above it is start to dropping here. It start to drop from here, okay? Now, as a result of this impact, the direction of velocity becomes horizontal. So whatever will be the velocity here, it becomes horizontal and it is like this. So let's say this is theta. Find the value of h upon h. So this is a pretty easy question here. So what is the distance covered is h minus h, right? So I can find the velocity by using third equation of motion. Initially u is 0, it dropped h minus h. So third equation will be v square is equals to u square plus 2as. Okay. So downside I'm taking as positive. So g is also positive and h minus h it is also positive. So v square will be u is 0 plus 2 plus g and s will be h minus h. Right. So we will turn out to be 2g h minus h. Very easy, right? And this velocity becomes positive. This velocity become horizontal. Okay. So let me rub it. This is the velocity here, right? So this is h minus h. Okay, perfect. It is saying find the value of h by h for the body for it will take maximum time to reach the ground, right? It will take maximum time to reach the ground, right? Okay, so it is a very interesting question. It will take maximum time to reach the ground. So our velocity is here, it is horizontal, right? Now, how can we solve it? Look, it has to go h in the downside. Okay, so the simple our question becomes is this. This is small h, this is our ground, and here we are giving the velocity. So to take maximum time to reach what it should be like, it should cover the maximum range possible. R should be maximum because if it falls down, it will be. But if it will go like this, right? So this velocity is constant. This is constant, and the range, the formula for range is v. Of course, this is horizontal into time of flight, right? Time of flight. So to be uh, so we need the maximum time of flight, right? To maximum time to reach the ground. So this must be maximum, right? So let's find the time of flight here. Let's find the time of flight here. So time of flight will be what? Can I use our three equation in y direction? Yes. So we will have y. What will have? Ux is 0. Okay. So I'm considering this as positive. So acceleration will be plus g, displacement will be plus h, and a velocity. I do not need the velocity. So we are going to find the time. So which equation I can use? S y. These are all y. Okay, these are all y. Sy will be uy t plus half a y t square. Uy will be 0. Sy will be h is equals to 1 upon 2. Acceleration will be 0 and this t square, right? So t turns out to be what? 2h by g root 2h by g, right? So I can put it here. So R max will be, what was V? Root 2g h minus h into root 2h by g. I can put these two here. Okay, perfect. Now, what will be the R max? R max will be root 2 to the 4, 2 multiply 2, and from GG we can cancel it out. It turns out to be h minus h into h, right? Now we need R. Okay, so this is just R, right? This is just R, right? To maximize it, we need to differentiate. Okay, with small h. Okay, small h is variable. Capital H is constant. Small h is variable. So what will we have? Half, and this whole will come out to be here itself. And differentiation of this. What will be that? 4. I can write it h minus h. So it will be h minus 2h, right? Chain rule I have used. That is very simple. So this is minus h, right? It should be 0. So this cannot be 0. This is only 0. So h minus 2h is 0. So h is equals to 2h. That will be h upon capital H upon, right? So what will be the ratio? So the ratio will be h divided by h will be 1 by 2, right? So 1 by 2 will be our answer. So yes, it is also an easy question. Nothing to worry about here. So it is also an easy question, right? So we have discussed what 3, 4, 5, and 6 questions we have discussed. Next, we'll move on to some other questions. Okay, perfect. This is our another question. It has come in ITG 2004. Let's see. A small block slides without frictionless down an inclined plane starting from rest. Okay. So Sn will be the distance traveled in t equal to n minus 1 to t equal to n. So this is the distance traveled in nth second, right? But the problem here is block slides on inclined plane. That is an interesting question. So let's say this is theta and this is our block. Now it is sliding on the inclined plane. So we know the acceleration of this will be what? Yes, the acceleration of this object will be what? A is equals to g sine theta. So I can clearly make the situation like this. This is our horizontal, okay? This is our block and it is moving with the acceleration g sine theta. Very easy. It is starting from rest, so u is what? 0. Now we know the formula of nth second. Yes, what was it? Sn will be u plus a by 2 to n minus 1, right? Simple. And u is 0, so formula will be u Sn equals to a by 2 to n minus, because this is 0, right? Now this is Sn. I need to find Sn plus 1, so a by 2, 2. I replace n with n plus 1, so n plus 1 minus 1. So a divided by 2, 2n plus 2 minus 1, right? We'll get this. 2 minus 1 will be 1. So answer will be a divided by 2, 2n plus 1. This is Sn plus 1, right? We need to find the ratio of Sn divided by ratio of Sn and Sn plus 1. So Sn divided by Sn plus 1 will be Sn will be a by 2, 2n minus 1 divided by a by 2, 2n plus 1, right? So a by 2 cancel. We do not need even the acceleration. So 2n minus 1 divided by 2n plus 1 will be our answer. So what? So this is again an easy question from equation of motion, right? Perfect. Next, we will be moving to next question. Sorry. Okay, perfect. So we have three questions here. Now, okay. So 88 is what? A ball dropped vertically from a height from a height d above the ground. It hits the ground and bounces up vertical to a height d by 2. Neglecting the subsequent motion and air resistance, its velocity v varies with the h height we have to find. Okay, so I'm making diagram. This is our particle. It is dropped from a height d, right? It reaches here, then it bounces back up. So this is the first path, right? Then it goes up to what height? D by 2. To what height? D by 2. Okay. This is our second path. So I'm writing these two paths in a different way. Okay. So what happens is this is our particle is going down, right? It is moving what distance d. So at here, initial velocity is what? 0. It is dropped, right? It is dropped. So dropping means initial velocity is 0. Now it is going downside. It is going down. Okay. So its velocity, its speed must be increasing. So velocity after it reaches here will be root 2 gh. You know that, right? How it comes out to be like that? Root 2 gd to be precise, because it is. We can use third equation. V square equals to u square plus 2as. V square, u is what, 0 plus 2 gt, right? So v will turns out to be root 2 g. Okay. Now this is at what, t equals to 0, and this is at some time t equals to t, right? What is happening is the speed is increasing from 0 to root 2 gd, but it is in the negative direction. So velocity is in negative direction. Okay, so downside I'm considering negative, and then upside I'm considering is positive. Okay, so you can take it otherwise, but we have to go with the options. Okay, so I'm considering downside as negative, so upside will be positive. This is for the first path. For the second path, what is happening is from here it is going up, right? Just the moment it hits, that is the same moment, right? I can say t1. So at that t1 instant, the velocity will be what? It will be some v dash. So velocity will be v dash. So it is going up to a height d by 2. So velocity will turn out to be 2 root 2 g. T by 2 will be root gd, but it will be positive. This is positive side, and here the velocity will comes out to be so 0, right? So let's make the graph. Okay, so at u equals to 0, the particle's position is d. So at u is equals to 0, let's use the pen. So u is equals to 0, particle position is d. Then at when it hits the ground, the particle position is 0. Now, when it starts to going up, the particle position is still h is equals to 0. But as soon as it reaches the d by 2, the particle position is what? Plus d by 2, right? This is all plus. Perfect. So how its graph will look like? I'm making this graph here. We have to make the graph v versus h. So v versus h. So at t equals to 0, initially the particle is at h is equals to d. So let's suppose this is h equals to d. Particle is here, and then the velocity is, the speed is increasing, but velocity is in negative. So the graph will be downside. And how it will be? It will be parabolic graph, right? Because v square will be 2 root v square will be what? 2gh. So this is the equation of parabola. So graph will be parabola. So particle will go like this. And as soon as its speed reaches root 2 gd, negative root 2 gd, right? The height will be 0. So height will be 0. It will hit the y-axis. Now, at the same instant, it will start to go up with the velocity root gd. So I said this is root gd, and this is what? Positive at x equal to 0. So it is starting from this y-axis itself, and it is go till h equals to d by 2. So it will go like this, right? So which option will be our answer? Okay, so like look, the downside I have considered negative. If you consider it positive and upside positive, then the graph will be exactly opposite and no answer will be matching it. So the downside is negative, and it is a general convention. The downside you consider negative, upside you consider positive. But you can choose any sign convention, answer will always comes out to be always correct. Okay, next, perfect. So this was our 88th question. Now Let's move forward to question number 96, right? So question number 96. What is a car accelerate from rest at a constant rate alpha after for some time, after which it deaccelerate at a constant rate beta to comes to rest. So this is a very easy question, I see. So as acceleration is given, I always try to make V versus T graph. Okay. So V versus T graph is very good. The area will give us displacement and the slope will give us acceleration. So always do this. Okay, perfect. So let's suppose for t1 time it is accelerating with alpha and then it comes to rest with the deceleration. This is a beta, and for what time? I say t2. Okay. The total time lapse is t. So clearly it is given t1 plus t2 is what? T, right? Find maximum velocity attained. So it is very easy, right? We have done it. Vmax. So let's write the equations first. This is I should write it as a time, right? Because t is some constant, so I should write it. This is our first equation. Second equation is slope. This alpha will equals to be Vmax divided by T1, right? The the beta is a constant. Okay, so it is a positive constant rate beta, so it's a positive. It is given. It is a constant rate, so it is a positive. So I just have to write the slope. So beta will be what? Vmax divided by T2. Vmax divided by T2. Okay. So I know this equation. So I don't know T1 and T2. So can I put the values of T1 and T2 in this equation? So first let's find the T1 will be Vmax divided by alpha. And from here T2 will be Vmax divided by beta. Remember, beta is a deceleration, but it is the rate. So it is always positive. The rate is always positive. So rate is given, so it is a positive quantity. So let's put it here. Vmax divided by alpha plus Vmax divided by beta is equals to T, right? So Vmax I can take it as I can take common and then LCM will be alpha plus beta divided by alpha beta is equals to T. So that is an easy question, right? That is an easy question. So Vmax will be alpha beta T divided by alpha plus beta, right? This is plus. Don't get confused. The B part is what? B part is total distance traveled. So just I have to find the area. Area will be half base, which is T, and height is Vmax. So this is an easy part. So distance will be half base and height will be Vmax. Just have to put Vmax here. So half T alpha beta T upon alpha plus beta. Sorry, alpha beta T square divided by 2 alpha plus beta. This will be our answer. Okay. Okay. Next. Yes. 97th question. Two balls of different masses are thrown vertically upward with the same speed. So of different mass. Oh, this is M1. This is M2. Okay. Look, we are studying kinematics. So mass it does not matter whatever the mass will be. Okay, the equation of motion will remain same. Vertically upward with same speed. Okay, so speed is same, so everything will be same. I think they pass through the point of projection in their downward motion. So like they are going like this and they pass here. Similarly, this is also going like this and this is pass here, right? With the same speed. Is it true? Yes, this is true. Absolutely. They will again move to the same speed. The mass, it does not matter. The equation of in the equation of motion, there is mass. It does not depend on mass, right? We know that, right? So it is true. That is a very easy question. So it is also easy. This is also an easy question, right? Perfect. The next questions we are going to discuss. Okay, let's discuss this question. Okay, so now we are going to discuss the questions based on vector. So this is our topic 3. Topic 3. Questions will be based on vectors. Okay, let's start. Just give me a second. Okay, perfect. Okay, so we have three vectors P, S, Q, and this is R vector. Okay, this is R vector, this PQ is R vector. Okay, this PS is given will be the distance is BR. This is the distance, okay? Okay, so I have to find S in terms of P and Q, right? I have to find S in terms of P and Q. Okay, so let's write whatever information we have. So first we can see this is a P vector. This is a this if I write this is this PS and this is our S vector. Okay. So how can I write it? P vector plus PS, P vector plus PS vector will be S vector, right? Okay, so PS, what can I write PS? It is in the direction of R vector. It is given, right? This R vector is what? Okay, so I should write it first. R vector is equals to Q vector minus P vector. Okay, so let's find what is this R vector. So this is our P vector. I can write it as P vector plus R vector will give us Q vector, right? So what is this P vector? P vector is this, right? This is our Q vector, right? So this must be our R vector, right? So if this is P, this is Q, then PQ is our R vector, right? This P plus R will give us Q. So R vector is nothing but this is our PQ vector. Okay, I just perfect. So this is our first. Okay, let's do one thing here. I have to write PS. So PS, the magnitude of PS is what? BR. So how to write? The magnitude of PS vector is what? It is given BR magnitude. And the direction of PS is what? R cap. So how can I write PS vector from here? PS vector I can write P magnitude of R and R cap, or magnitude of R cap will be what? R vector itself. So PS I can write, so this I can write it again, P vector plus B R vector is equals to S vector, right? This is our first equation. Next, I have to write S vector in terms of P and Q. So can I put r here? Yes, let's put r vector here, which is q minus p. So let's put it. So p vector plus p. R vector is what? Q vector minus p vector is equals to s vector. We got our answer. So just adjust it. This was our first, this was our second. So from first and second we have done this. Let's adjust it. This is our s vector. We can write p vector plus bq vector minus bp vector, right? So it will be bq vector plus p vector 1 minus p is equals to s vector, right? This is our answer. That is an easy question. But again, it is an interesting question. So 1 minus bp vector plus bq. Okay, so a itself, right? That was an easy question. Okay, perfect. This is the last question which we are going to discuss today. Perfect. So we have two vectors. We have a vector, a I cap, and we have another vector, b vector will be a cos omega t I cap plus sine omega t j cap, right? It is given that is constant omega is pi by 6. We have to find this at time t equal to tau, and we have to find. Okay, so let's first write a vector plus b vector. What will be, so I the component in I cap will be added to I cap. So it will be a plus a cos omega t I cap plus it's a sine omega t j cap. Now let's write a minus b vector. A minus b vector will be what? A vector minus this. So it will be a minus a cos omega t I cap minus a sine omega t j cap. Now let's find the magnitude of these both. It will be under root. So a I can take common. It will be 1 plus cos omega t square plus sine omega t square, and it will be what? A again I can take common, 1 minus cos omega t whole square plus sine omega t square, right? And these two are equal, so we can write a root. So if I open it, 1 plus cos square omega t plus 2 cos omega t. That is an easy question, right? Sine square omega t is equals to root 3 a under root 1 plus cos square omega t minus 2 cos omega t plus sine square omega t, right? Okay, so we can square both sides. So a will get cancelled out, and if we square, this is 1. This is what? 1 plus 2 cos omega t, and we have squared it. So root 3 will become 3. And again, this is 1 plus this is again 1 minus 2 cos omega t. Okay, yes, sine square theta plus cos square theta will be 1. Oh, so this answer will be 2 plus 2 cos omega t is equals to 3 to just 6, 3 to just 6 cos omega t comes here with the plus, so 8 cos omega t, and this comes here, so this is 4. So cos omega t will be what? 1 by 2, right? So omega is, so when does it happen? Omega t must be equals to what? 60 degree. Omega is given pi by 6, which is 30 degree, right? So let me write it in radian. So 60 degree, what you can write in radian will be pi by 3. Omega is what? Pi by 6 into t is equals to pi by 3. Pi, 3 2 ja. So t will come out to be 2 seconds. T will come out to be 2 seconds. Yes. So it is an easy question, right? Okay, perfect. So again, this is an easy question. So we have discussed like 13, 14 question today. Okay. So every day I will try to post a video where I will be only discussing J Advanced questions in extreme details. Okay. Thank you everyone.